Asha from LG Institute of Engineering and Technology from the Department of Electronics and Communication Engineering. Today I am going to explain you about the topic exponential distribution from the subject of probability and statistics. In the last session we had seen about this normal distribution. Now the next distribution is exponential distribution. What is exponential distribution? A continuous random variable x is said to follow exponential distribution if its probability function is given by f of x equals to lambda into e raised to minus lambda x. For x is greater than 0 and for x less than or equals to 0, its value equals to 0. Now, there are some important points of this exponential distribution. The first point is it has memoryless property, means it will consider as forgetfulness property. It means occurrence of any distribution does not depending on occurrence of any another event. So it will be independent to any event, so it will consider as memoryless distribution. In this exponential distribution, the value of mean equals to 1 upon lambda and the value of variance equals to 1 upon lambda square. So we will using these equations in solving some examples based on this exponential distribution. So the first example is, let x be a random variable with probability density function PDF f of x equals to 1 upon 5 e raised to minus x by 5 for x greater than 0 and for x less than or equals to 0, its value equals to 0. For this particular PDF, we have to find out its mean, variance, then we have to find out probability of x greater than 5 and then we will find in the probability of x in between 3 to 6. Now you can see that this particular function f of x equals to this, comparing this equation with this equation. So you know that the value of lambda equals to 1 by 5, right? Because here also the value of lambda, if I am putting lambda equals to 1 by 5, then the equation will be like this, right? So what is the value of lambda? The value of lambda equals to 1 by 5. From this, we will taking the value of lambda equals to 1 by 5. Now we have to find out mean value. What is the mean value? Mean value equals to 1 by lambda, right? So we will taking 1 upon 1 by 5. Same way we have to find out variance. For that we will taking 1 upon lambda square. So in this, instead of lambda I am taking 1 by 5. So if I want to solve this example, then starting with f of x equals to 1 by 5 e raised to minus x by 5. This one is for x greater than 0. Otherwise, its value is 0, right? Means for x less than or equals to 0, its value equals to 0. So we'll comparing this with f of x equals to lambda e raised to minus lambda x for x greater than 0 and for x less than or equals to 0, its value is 0. So if we are comparing this, you can see that the value of lambda equals to 1 by 5, right? So the value of lambda equals to 1 by 5 and from this, if you want to find out mean value, what is the mean value? Mean value means 1 by lambda. So if we put in the value of lambda, then the value is 1 upon 1 by 5. So as you know that 1 upon 1 upon 5, so its value equals to 5. Same way, we will finding the value of variance. So what is the value of variance? As you know, the equation of variance for this exponential distribution is variance equals to 1 upon lambda square. Now we will put in the value of lambda equals to 1 by 5. So its square equals to 1 upon 1 upon this, means its value equals to 25, right? So this way we had find the value of variance. Now we have to find out the value of probability of x greater. So if you want to find out probability of x is greater than pi, then how will finding this probability? As you know that the equation of it is integration for the entire range, means minus infinite to infinite f of x dx, right? f of x is already given to you, so we will put in this value as we have to take range greater than 5. So if I want to take greater than 5 means we have to take this value. So what will be the range? 5 to infinite. So what will be the range over here? The range is 5 to infinite. What is the value of f of x? It is given to you as 1 by 5 e raised to minus x by 5 dx, right? Now 1 by 5 is constant, so it will be outside of this integration. What is the integration of e raised to minus x by 5? Its value is e raised to minus x by 5 upon minus 1 by 5. This one is 5 to infinite. So if I am simplifying this term, so what will be the term? E raised to minus infinite minus e raised to minus 5 by 5 upon minus 1 by 5, right? So if I am simplifying this, as you know that e raised to minus infinite means 0. So 0 minus this value means minus term, minus minus cancel out. This one is 1 by 5, 1 by 5 is cancelled out. So overall answer is e raised to minus 1. 5 by 5 is cancelled out, so this one is e raised to minus 1, and if we are finding the value of e raised to minus 1, then its value equals to 0.3679. So this way we can find the probability of x which is greater than 5. Now we have to find out probability of x in between 3 to 6. So if I want to find out this, then the equation will be from 3 to 6. If we are integrating f of x dx, then we can find out probability of it. Right, so we'll put in the value of f of x over here, so the term will be 3 to 6. Instead of f of x, I will take 1 by 5 e raised to minus x by 5 dx. Same way to this, instead of this, we will taking 6 and here we will taking the value equals to 3. So if we are solving by the same method, then the next term is e1 by 5 is constant, e raised to minus x by 5 upon minus 1 by 5, the range will be 3 to 6. So if I am putting first, instead of x, if I am taking x equals to 6, then I will take x equals to 3. Then the term will be 1 by 5, 1 by 5 will be cancelled out, so the term will be minus e raised to minus 6 by 5 minus minus plus e raised to minus 3 by 5. So if I am solving this particular value, then answer of it equals to 0.2476. So this way we can find out probability of any random variable x in between any range. Now the next example is a random variable has PDF f of x equals to c into e raised to minus 2x, x is greater than 0. Find the value of probability of x is greater than 2. Probability of x is less than 1 by c. So if I want to find out this probability, for that you had given this particular function, right? In this, as you know that the value of c is not given to you. So first of all we have to find out the value of c. So how will finding the value of c? As you know the properties of PDF, what is the property of PDF? If we are integrating the probability density function over the entire range, then the value of it equals to 1. So we will use this property to solve this example. So we will integrating f of x for the entire range from minus infinite to infinite. So f of x dx, it should be equals to 1. So in this I am putting the value of f of x. What is the value of f of x? Its value is c into e raised to minus 2x. So in this we will taking the value of x is greater than 0, right? So I am taking 0 to infinite. Greater than 0 means starting with 0 and greater all the values, so 0 to infinite range. So if I am taking this particular value, then the term will be 0 to infinite, c into e raised to minus 2x dx, it should be equals to 1. Now if I am integrating this particular part, then we can find out value of c. So I am taking c as a constant part outside of this integration, so the term will be e raised to minus 2x. I am integrating this term as e raised to minus 2x upon minus 2. The range will be from 0 to infinite. So this should be equals to 1, right? Now c will be as it is. Instead of x I am putting infinite, so it will be considered as minus infinite. Because minus 2 into infinite means minus infinite, right? And the value of 0, if we are putting x equals to 0 over here, then the term will be e raised to 0 upon minus 2. So e raised to minus infinite means 0. e raised to 0 means 1 divided by minus 2. This should be equals to 1. Now 0 minus 1 means minus 1 divided by minus 2. So minus minus plus 1 by 2. 2 goes over here. So the value of c equals to 2. So first of all we had find the value of constant c equals to 2. So if I am putting the value of c over here, then the term will be 2 into e raised to minus 2x, right? So this one is the final function of f of x. Now from this we have to find out probability of x is greater than 2 and probability of x is less than 1 by c. 1 by c, instead of c I will put value of c equals to 2. So starting with the first term, we have to find out probability of x which is greater than 2. So if I want to find out this, you can see that x greater than 2 means if I am taking this, so 2 to greater all the value means we are taking the range as 2 to infinite, right? So I am taking integration over 2 to infinite f of x dx. In this I am putting the value of f of x as 2 into e raised to minus 2x dx, right? Because we had taken the value of c equals to 2. So if I am integrating this particular part, 2 will be constant, so it will be outside of integration, and integrations will be for e raised to minus 2x means e raised to minus 2x upon minus 2, and the value of it range will be 2 to infinite. So if I am putting the value of it in this over here, then the term will be e raised to minus infinite minus, if I am putting 2, then the value is 2 into 2 means 4 divided by minus 2. As you know that the value of e raised to minus infinite equals to 0, so this value will becomes equals to 2 into this one is 0 minus e raised to minus 4 divided by minus 2, right? 2 will be cancelled out, this one is minus, 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 minus will be cancelled out, so the final term will be minus minus plus e raised to minus 4. Now if I am finding the value of e raised to minus 4, then the answer of it equals to 0.0183. Same way we have to find out the probability of x which is less than 1 by c, right? So the next thing is, in this we had given the value of c and we had already find the value of c as 2. So what we have to find out? We have to find out probability of x which is less than 1 by 2. If I am putting the value of c equals to 2, right? So this one is the final term. Now if I want to find out this particular thing, then how will finding this value? It will be find as this, taking this one as 1 by 2. So we have to take less than 1 by 2 means from range from minus infinite to this 1 by 2. So what will be the equation? The probability for this we have to take taken as minus infinite to 1 by 2. This term will be f of x dx. Now instead of this f of x, I will take the value. So the term will be 2 into e raised to minus 2x dx, right? If I am drawing the graph of this, you can see that if we dividing this whole part minus infinite to 1 by 2 into 2 parts. This one is first part from minus infinite to 0 and from 0 to 1 by 2. So for this the value of x equals to 0. So we are removing this particular part. So it will give you the term from 0 to 1 by 2 only, right? So this range will convert in the form of 0 to 1 by 2 only. So the next thing is we will finding the probability of x which is less than 1 by 2. For this the range will be from 0 to 1 by 2 and the term will be 2 into e raised to minus 2x dx, right? Now if I am solving this particular thing, 2 will be constant, so it will be outside of this integration. E raised to minus 2x, its integration is e raised to minus 2x upon minus 2. This will be from 0 to 1 by 2. So if I am putting this value e raised to minus 2 into, instead of x I am taking 1 by 2 minus e raised to 0 divided by minus 2. So 2 will be cancelled out, this minus goes over here, so minus minus plus e raised to 0 means 1 minus 2 will be cancelled out, so the term will be e raised to minus 1. So 1 minus e raised to minus 1, and if we are finding this value, its answer is 0.6321. So we can find out probability of any random variable x for any range by using this exponential distribution. Thank you so much.